going to start off with Chapter 1 stuff, learning about measurement. So the basic, we want to know about the basic units of measure. We're going to be looking at mass, and we're going to be looking at length, and also time. There's some other basic units of measure that we'll talk about in a second. Well, let me just throw temperature up here as well. We will get to temperature, but not quite yet. There's some other units of measure you may see later on in the course, but for now we're going to focus on these four. Mass is going to be measured in units of grams. We're going to call that the basic unit of mass. The mass of a paperclip is about 1 gram. The basic unit of length is the meter, where length is the distance between 2 points. Meter is about that wide. Time, I think we're all familiar with this. The basic unit of time is the second. And of course, there's other units of time like minutes and hours and years. And then temperature, the basic unit of temperature, you may not be familiar with this, it's called the Kelvin. And all of these have abbreviations that are associated with them. So the abbreviation for gram is just a little g. So anytime you see a little g, you should recognize that that's going to be associated with a gram. The abbreviation for a meter is a little m. The abbreviation for a second is a little s, and the abbreviation for Kelvin, that's going to be a capital K. So slide 2, we're going to worry about temperature. And I'm going to define temperature here. Temperature is the average kinetic energy of particles in a system. So you can think of it about as temperature as how fast the particles in a system are moving. In a sense, for now. On average how fast they're moving. And we have this unit of temperature that we call the Kelvin. We also will sometimes use a unit of temperature called degrees Celsius. So this would be written as degrees Celsius. Oh, I spelled that C out. That's it. And you're probably familiar with temperature in units of degrees Fahrenheit. You know, when we say it's a summer day, it's 80 degrees. What we really mean is it's 80 degrees Fahrenheit. If we were using that measurement in Celsius, that'd be more around maybe 28 degrees Celsius. And in Kelvins, 80 degrees Fahrenheit, that'd be roughly 298 Kelvin. So all of those measurements mean the same thing, but they're just different units of measure. And we're going to learn how to convert one into another. So let me just write this here. This is degrees Fahrenheit. And let me talk a little bit first about each of these different ways of measuring temperature, sort of how these different measuring systems came about. We'll start with Fahrenheit. Fahrenheit had this idea that he could take a glass ampule and seal it with a liquid in the bottom. And when that liquid was placed in something hot, the liquid would expand, and then the liquid would go up a small capillary in the middle of the tube. And when that ampule was placed in something cold, the liquid would contract, and that would cause the liquid in the small capillary to drop. And so all Fahrenheit did is he said, you know what, we're going to call 100, we're going to call that human body temperature. So that's what 100 degrees Fahrenheit was set at. And then Fahrenheit found that the coldest mixture he could achieve was a mixture of ice, salt, and water. And that was as cold as he thought things could get. And so he said, well, we'll call that 0. That makes sense. So this mixture of ice, salt, and water was set at 0. So this was called 0 degree Fahrenheit. Human body temperature was called 100 degree Fahrenheit. And then they just made 100 divisions in between those 2 points. And that's the way the Fahrenheit temperature scale came about. Well, that's probably not a real good way to use a measuring system, because obviously, your temperature varies whether you have a fever or not. And so people thought, well, maybe there's a better way to do this where we can use an actual consistent measure that doesn't change. And this is what Celsius came up with. Celsius said, okay, we're going to set 0 at the freezing temperature of water, which pretty much doesn't change. I mean, it will with altitude and other things, but it's pretty constant. So we're going to set 0 at the freezing temperature of water, and we're going to set 100 at the boiling temperature of water. So the same thing is done, but in the Celsius scale, 0 is set at the freezing temperature of water, which on the Fahrenheit scale, you might know that's 32. You might know that. And then at the other end, they set Celsius set 100 at the boiling temperature of water, which in Fahrenheit, that's 212. Turns out to be 212 Fahrenheit. So nevertheless, that gives you an idea of how these 2 different temperature systems were based. The Kelvin system, I really like the Kelvin system because it gives you an idea of what's really going on. Now, temperature is really a measure of the kinetic energy of particles, an average of how fast they're moving. If they're not moving at all, that would be like 0 temperature, wouldn't it? And that's the idea on the Kelvin scale. On the Kelvin scale, we set 0 Kelvin at the place where molecular motion, for the most part, ceases. I'm lying to you a little bit. Things still move at absolute 0. But for this class, we can really think about molecular motion stopping. There's no molecular motion at all at absolute 0. And that's what we do. We set 0 Kelvin at absolute 0. Now, you can't get there. You can't actually get to absolute 0. You can get really close, but nevertheless, 0 Kelvin is the spot where you can't get below that in temperature. You actually can't get to it, and at that point, molecular motion ceases. So let's see how we can convert from one of these into another. There's a couple equations that I'm going to write down that'll help us to be able to do this. Okay, so conversions from degrees Celsius to Kelvin, we're going to use this equation. Degrees Celsius, that's going to be whatever your Kelvin temperature is minus 273. For conversions between, let's also show this. I mean, this equation is used if I have the Kelvin temperature and I want to know what the Celsius temperature is. So, for example, if I have 0 Kelvin, which is absolute 0, we can ask the question, well, what's absolute 0 in degrees Celsius? Now, notice, I've been given the Kelvin temperature. I want to find Celsius, so I use this equation here. So I just plug in 0 here. So degrees Celsius, that's going to be 0. That's the Kelvin temperature I'm given. I'm going to subtract 273. And of course, we get minus 273. So 0 Kelvin is the same thing as minus 273 degrees Celsius. That's absolute 0 on the Celsius scale. We might also want to use this equation if I'm given a Celsius temperature and I want to know what the Kelvin temperature is. In that case, we're going to have to do a little algebra here. If I just add 273 to both sides of this equation, of course this cancels here, and I see that my Kelvin temperature, to find that, I'm just going to take whatever the degrees Celsius temperature is and add 273 to it. That's simple. So for example, we know that 100 degrees Celsius, that's the boiling temperature of water. What's the boiling temperature of water expressed in kelvins? I just take that 100 degrees Celsius, I plug it in there, and I get 100 plus 273. That's going to be 373 Kelvin. So, 100 degrees Celsius is the same thing as 373 Kelvin. It's the same temperature expressed in 2 different ways two different unit measuring systems. You should know how to do this. All right, now let's look at Fahrenheit to Celsius conversions. So we can use this equation here. Let's say I want to know what a Fahrenheit temperature is if I'm given a Celsius temperature. If so, I use this equation here. Degrees Fahrenheit is 9/5 of degrees Celsius, and then we're going to add 32. So let's just see this. We're 100 degrees Celsius. That's a boiling point of water, right? And I told you that that's the same thing as 212 degrees Fahrenheit. Let's use this equation here to see if that's actually the case. All right, let's run it. So I'm given a Celsius temperature, 100, and I want to know the Fahrenheit temperature. Okay, so let's see, my degree Fahrenheit, that's going to be 9/5 of whatever the Celsius temperature is, which we know that's 100. We're given that. And then we're going to add 32. What's 9/5 of 100? 100 divided by 5, that's 20. 9 times 20, that's 180. Hey, look at that. 180 plus 32, there we have it. 180 and 32, that's 212. So this tells us, this equation tells us how to find a Fahrenheit temperature if we're given a Celsius temperature. What if we want to go in the other direction? In the other direction, we're going to have a Fahrenheit temperature, and we want to know what the Celsius temperature is. Let's do a little bit of algebra on this equation so we can look at how that works. Okay. Let me just make this a little clearer. All right, I want to get degrees Celsius alone on one side and everything else on the other. So I'm going to subtract 32 from both sides. And if I do that, I get degrees Fahrenheit minus 32. That's going to be the same thing as 9/5 degrees Celsius. I got to get that degrees Celsius alone. So to this side of the equation, I'm going to multiply it by 5/9. That's going to cancel this. Whatever I do to this side of the equation, I have to do to this side of the equation. So since I multiplied this side of the equation by 5/9, I have to multiply this whole side of the equation by 5/9. And so the equation I end up with to find Celsius, if I'm given Fahrenheit, is degrees Celsius is 5/9 of degree Fahrenheit minus 32. So let's use this equation to see if we can get a numerical value for the Celsius temperature of human body temperature, which, you know, Fahrenheit must have had a fever when he said 100 Fahrenheit was human body temperature, because most of us see it as 98.6. Or maybe he was just a little bit hot-natured. We don't really know. But anyway, we're going to take this 98.6 degrees Fahrenheit, we're going to plug it in here, and we're going to try to find out what is the degrees Celsius value for human body temperature, which is 98.6. So let's do that. Degrees Celsius, that's going to be 5/9 of 98.6 minus 32. From our order of operations, we got to make sure we do what's in the parentheses first. So what is that? 98.6 minus 32. Is that 66.6? I did my math right? I'm going to get out my calculator for this part. Okay, so I'm going to take, let me just make sure I did that right. 98.6 minus 32. Yep, that's 66.6. I'm going to multiply that by 5, and I'm going to divide that by 9. I get 37. So 37 degrees Celsius, that's going to be our temperature, human body temperature in units of degrees Celsius. All right, what's that going to be in kelvins? Let's use that equation we had before. Do you remember it? What's that? Kelvin equals degrees Celsius plus 273. Just plug that in. And 37 and 273, that comes out to 310 Kelvin. So body temperature, human body temperature in kelvins is 310 Kelvin. So what I'd like you to do now, I'm going to give you a problem to do, work on it, and then once you work on it, come back and we'll see if you did it right. I want you to calculate what is absolute zero in units of degrees Fahrenheit. There's going to be 2 steps there. So I want you to calculate absolute zero in degrees Fahrenheit. And notice there's going to be 2 steps here. Remember, 0 Kelvin, that's absolute zero. Got to get that converted to Fahrenheit. All right, hopefully if you've given this a shot, I'm going to work you through this problem, see if you've done it correctly. First step, I'm going to take my Kelvin temperature and figure out what that is in degrees Celsius. Well, my degrees Celsius temperature, that's going to be your Kelvin temperature, minus 273. We already did that. You've seen that before. So if it's 0 Kelvin, I'm going to plug a 0 in here, and it's pretty easy to see that 0 degrees Celsius is minus, 0 Kelvin, is negative 273 degrees Celsius. So we have that. Now that we have our degrees Celsius temperature, we can convert to Kelvin using this equation. To Fahrenheit. Degree Fahrenheit, that's going to be 9/5 of my degrees Celsius temperature. And we're going to add 32 to that when we get done. So I'm going to take this negative 273 and plug it in here. 9/5 of minus 273 degrees C. We'll add 32 to that when we're done. That unit won't go in there. Get out my calculator. 273, I'll make it negative. So I should have a negative 273. I'm going to multiply that by 9. I'm going to divide that by 5. And I get minus 491.4. Minus 491.4. And if I add 32 to that, I get negative 459.4 degrees Fahrenheit. Ooh, that's cold. Minus 459.4 degrees Fahrenheit is our temperature, our Fahrenheit temperature at absolute zero.